Hello everyone, I'm Eli, a GRE trainer here at the International Scholars Program. So welcome to our GRE training series. Today we'll be looking at a couple of tips and examples for quantitative comparison questions. So welcome and let's begin. Now, the first tip is that for quantitative comparison questions, you don't have to do all the calculations until you get the actual answer. What matters is that you can compare quantity A and quantity B and actually determine the relationship between the two. So once you can do that, stop and pick your answer. You realize that with the GRE, it's not just whether you can do a question, but also it matters how fast you can do it. Most questions you should be able to tackle in approximately a minute or a minute and a few seconds, depending on the difficulty level, right? And so given that you are dealing with time constraints, if you have to do every calculation until you get to the exact or accurate answer, you'll be wasting time. So the tip is just to do enough calculation to help you determine whether quantity A is greater than quantity B, or the two are equal, or B is greater than A, or you cannot determine the relationship. So once you can do that, stop and pick your answer. And in many cases, this will call for you to round off the figures you are dealing with to whole numbers, that is integers, because these are fundamentally easier to deal with compared to fractions or decimals. For example, say you want to compare quantity A, which is 950 raised to power 2000, and quantity B, which is 10 raised to power 6000. So if you want to compare these two quantities, you can see that 950 raised to power 2000 is kind of an ugly or complex looking figure. But if you know that you can use approximation, you can do this in under a minute. Because, for example, 950 is approximately 1000. That is, 950 is just slightly less than 1000, and 1000 is 10 power 3. So instead, you can use here 10 power 3, and then this one is raised to power 2000, and 10 power 3 raised to power 2000, that is 10 raised to power 6000. So you are comparing this to this. But remember, your actual figure is something slightly less than 10 power 6000 because you approximated upwards. So the actual figure for quantity A is something slightly less than 10,000. So if these are equal and you approximated upwards, it means in actual sense, quantity A is slightly less than this, meaning quantity B is greater than quantity A. Now, the next step is to do matching operations on both quantities. So quantity A, because for quantitative comparison questions, we have quantity A and we have quantity B. So you can do matching operations on both quantities so that you can simplify them for ease of comparison. Because if you have complex, for example, you have algebraic expressions in quantity A and the same in quantity B, or just in one of them, it would be difficult to compare them without knowing what the values are. But doing matching operations on both quantities can help you simplify them. And by matching operations, we mean whatever you do to quantity A, you do to quantity B. Think of this like an equation with an equality sign. Something like this. Whatever you do to quantity A, you do to quantity B. But for these cases, there are only a few operations that you can do without changing the fundamental relationship between A and B. And that is very crucial, because if you change the fundamental relationship between quantity A and quantity B, you will end up with an erroneous comparison and your answer will be wrong. So the first thing you can do is you can add equal values to each quantity. For example, you can add 5 to quantity A and add 5 to quantity B. Subtraction will also work. You can subtract a figure from quantity A and the same figure from quantity B. But when it comes to multiplication, only do the operation if you are dealing with a positive value. That is, if you are multiplying by a positive value, you can do that. So you can multiply quantity A by a positive value and also quantity B by the same positive value. Don't do the multiplication with a negative value, because that will change the fundamental relationship between quantity A and quantity B. We want to go into the proof. We want to look into how we can prove that, but just know that for multiplication, only deal with positive values. The same, if doing matching operations for quantitative comparison questions, and you want to do division, also only deal with positive values. For example, you can divide quantity A with positive 2 and quantity B with positive 2, but not with a negative, because that will also alter the fundamental relationship between the two. Now, let's look at some specific examples and see how we can do them very fast using what we have just learned. So let's look at this one. Yesterday, a certain school had an equal number of boys and girls. Today, 18 boys left the school, and the ratio of the number of boys to girls is now 3 to 4. So we want to compare the number of boys in the school now and 72. Now, of course, these questions also, apart from the tips we just discussed, you also need to get the fundamental mathematics right. So the first thing here, let's understand what this question stem is talking about. Yesterday, a certain school had an equal number of boys and girls. So let's say for yesterday, we had X boys and X girls. And because we are dealing with the number of people, X is automatically a positive number. Today, 18 boys left the school. So today, we have X minus 18, but the girls, we still have X. And the ratio is 3 to 4. So boys to girls, we have X minus 18 to X, or we can say X minus 18 over X, and that is 3 to 4. Okay. So what can we do from here? Well, we can multiply this to simplify it so that we can know what X is. 4 over 3. This side also 4 over 3. So that we have 4x minus 72 over 3x being equal to 1. So from there we can have 4x minus 72 being equal to 3x, or 4x minus 3x being equal to 72. And we know that our x is 72. Now, from here, what do you think our next step should be? Now, it might be tempting maybe to go further with the calculation because you know that X was the original number of boys, and now maybe to find the current number of boys, but that is a waste of time because we have quantity A as the number of boys in the school now, and we know that the number has reduced. The original number, that is X, is 72, and the number has reduced. We don't even need to calculate the reduction. Knowing that it has reduced is enough to stop the question now and pick our answer because quantity B is 72. Quantity A is something less than 72. So our answer is quantity B is greater.
You are watching Success with Bob Mwiti Show, presented to you by the International Scholars Program. The International Scholars Program is an award-winning international education financing scheme that helps bright students to pursue graduate studies abroad regardless of their financial background. You can find our programs by going to www.internationalscholarsprogram.com. The International Scholars Program, empowering dreams.
Let's look at another example. Now we have P plus Q, 1, and then 0 less than P less than Q. This one you can also write as Q greater than P greater than 0. And this tells us that both P and Q are positive because anytime a number is greater than 0, the number is positive. So that one is significant because it can help us simplify the two quantities. Remember we said for multiplication or division, you can only do matching operations if the operations you are doing involve positive values. So here we already know that Q and P are positive. That means we can multiply quantity A with PQ and quantity B also with PQ. Here we'll end up with positive 1, and this side will end up with PQ. And remember, both P and Q are positive, and if you add them, you get 1. So what does that tell us? That shows that both P and Q are positive. P and Q are positive fractions. And anytime you multiply positive fractions, and the fractions are, of course, each is less than 1, because if they add up to 1, it means each fraction is less than 1. If you multiply the two, the answer will still be less than 1. And so we can stop here and pick automatically that the answer is the quantity in column A is greater. Very fast. Okay, we have another one here. Quantity A, quantity B, we can see some unknowns, X, but we are not told anything about X, so it can be any number. Okay, but before we can determine the relationship, remember what we said. Looking at this, you really can't know, because this is not something you can compare without further simplification. So let's try and see how we can simplify them. Let's start with the quantity A. We have X plus X into bracket. This one we can have as X plus X, that will be 2X plus 1 squared. Now, remember the identity A plus B squared, giving us A squared plus 2AB plus B squared. We can use this relationship, this identity, to expand this bracket in a few seconds. So this one can be 4x squared plus 4x plus 1. Okay, so we can stop there, and then let's look at quantity B, which you can have using the same identity. We'll have x squared plus x squared plus 2x plus 1, which can be 2x squared plus 2x plus 1. Now, once you have this, we can now do our matching operations. And here we'll be dealing with subtraction, because you can see that we have the same terms of x in both columns. We have x squared, we have x squared, we have x, we have x. So a subtraction can work to simplify things here. And with subtractions, we don't mind whether x is positive or not. So let's subtract this whole term, that is 2x squared plus 2x plus 1 from both columns. So if we subtract, so let's just write it here, 2x squared plus 2x plus 1. We do the subtraction, we'll end up with 2x squared plus 2x. On this side, we'll end up with 0. So we have simplified this to mean that we are really comparing 2x squared plus 2x as quantity A, and we are comparing that with that expression with 0. But because we don't know actually what x is, it can be an integer, a fraction, a positive number, or even a negative number. It means from here we can pick numbers. So if x is 0, for example, then it means quantity A and quantity B will be equal, and our answer will be C. But what if x is 0? What if x is not 0? If x is not 0, the relationship might change. For example, if x is 1, then we'll have 2 plus 2, which is 4, and 4 is greater than 0. So being that we are ending up with the conflicting values for quantity A, depending on the value of x we pick, our answer here is that the relationship cannot be determined from the information given. Now let's look at our last example. Another quantitative comparison question. Body mass index BMI is calculated by the formula, that one, where W is the weight in pounds and H is the height in inches. So we have quantity A as the number of pounds gained by a 74-inch tall person whose BMI increased by 1. And we have quantity B, the number of pounds lost by a 65-inch tall person whose BMI decreased by 1.2. So we are comparing weights. So it makes sense to make weight the subject of this formula as the first step. So BMI, let's represent that with B. So let's say B is given by 703 W over H squared. Okay, then W, we can say that BH squared is 703 W, and that means W will be BH squared over 703. Okay, where W is the weight. Now for quantity A, we want to calculate the weight of a 74-inch tall person whose BMI increased by this. So the weight again. So here we'll have B is 1, H is 74. So we have 1 times 74 squared over 703, which is that 74 squared over 703. For quantity B, we have the weight gain as the B now is 1.2. The height is 65 plus 703. Now, from here, we can do matching operations to get rid of the common term here, which is 703. So we can do 703, then also again times 703. So now we are comparing 74 squared and 1.2 times 65 squared. Now, we are dealing with weight and height of a person. So we are dealing with positive numbers. And that means we can do matching operations of finding the square root here for both terms. So the square root of 74 squared, that will be 74. And the square root of quantity B here will have the square root of 65 squared as 65. And this one will be root 1.2. So from here, we are comparing 74 with 65 root 1.2. Now, again, let's see, approximation. Square root of 1.2 is approximately 1.1 because 1.1 squared will give you 1.21. So we can say that this is 65 times 1.1, which will be something like 65 plus 6.5. And if you add this, you don't even need to bother about the fraction. As you can see, you can add 65 plus 6. So quantity B will be 71 point something. So from there, you can see that quantity A is greater than quantity B. So this is our answer. So again, you can see how matching operations and approximations can help you. Because for quantitative comparison questions, all we are interested in is to determine the relationship between the quantities in the two columns. You don't need to be very precise or accurate with your arithmetic operations. So matching operations and approximations really help with these questions. So that brings us to the end of our GRE series today. But of course, these are not the only tips you can use with quantitative comparison questions. There are more, and if you want to know more about them and even other GRE quant questions, we welcome you to enroll in the International Scholars Program, where we have a comprehensive training of the GRE. So that is all for today. Welcome back next time. Bye.